one-to-one functions and inverses. Now, a one-to-one function is a function in which every element of the range corresponds to exactly one element in the domain. So again, make sure that we have a function. So we already have that for every function in the domain, there's exactly one element in the range. And now we're really saying the other way, that if every element of the range, there has to be exactly one element in the domain. Or in other words, we could say that for every input, there is exactly one output, which is really the definition of the function. And at the same time, we have that for every output, there is exactly one input, which is the part about one-to-one. Now if we go back to our month and number of days example, we have, looking at just part of it, we have January, February, March, and April. Now this was a function because we knew exactly where January would go. The one output would be 31. If we're looking at 28, February would go there. If we're looking at March, that would go to 31, and April would go to 30. So we have this mapping of the month and the number of days. So we know that this was a function since each input had exactly one output. You plug in January, you knew exactly what you get. Now on the other hand, this function is not one-to-one, since if you look at the output of 31, it comes from both April and January. January and March. So basically, you're looking at the range now and seeing where that came from. The range, this element in our range, this output, needs to have only one input. Otherwise, it's not one-to-one. Now we have another test if you're looking at the graph to determine if it is one-to-one or not. So let's look at this example of our x squared function. Now we already know that this is a function. Okay, so then if we want to check if it's one-to-one, we need to make sure that every output has exactly one input. If we switch our line around to be horizontal, we can see that this is corresponding to some particular y value, and it actually has two different x values. In particular, we could look at this y value of 4. Let's make this into 4. So if y is equal to 4, this comes from x equals 2 and also x equals -2. So for this one output, we have two inputs. So that means that it is not one-to-one. And you can see that this occurs throughout the graph. We call this the horizontal line test. And basically, if the horizontal line crosses graph more than once, it's not one-to-one. Let's consider one more graph, something a little different here. So first, we make sure that it's a function. It is. It passes the vertical line test. And then to check for one-to-one, we make our horizontal lines. And you can see that for every y value, there's exactly one x. So one-to-one checks out as well. Now we want to look at inverse function. So if you have a function, let's say f of x equals 2x. This function takes every input and it multiplies it by 2. So we can say that you put something in to our f, and we get our output. In our case, our output is 2 times what we put in. Now, we could think about trying to go backwards with this. If we want to undo that multiply by 2. So let's say we're starting with our output, and we want to go all the way back to our input. That would mean that we would be talking about something called f inverse. And it would have to actually do the opposite of multiplying by 2. We would have to divide by 2. So for example, let's look at if we have the inputs 1, 2, 3, and 4. So we know that our function f of x doubled each of these values. It multiplies it by 2. So we have 2, 4, 6, and 8. So the inverse function would do the exact thing but in reverse. So our inverse function, if you have a 2 was your original output, we're going to start with that input and we want to get back to where we started, which is 1. So 2 goes to 1, 4 would go back to 2, 6 would go back to 3, and 8 would go back to 4. So really we could think about the inverse function as switching the inputs and the outputs. Or we could say the domain and the range. Now we could look at the graph of each of these things. And again, I'm going to label this function as f inverse. So this first table, referring to x, we have the value 1 getting mapped to 2. We have 2 going to 4, 3 going to 6, and 4 going to 8. So we're getting this line. So this is our function f. Now if we look at the function that we're calling the inverse, 2 gets mapped to 1, 4 gets mapped to 2, 6 gets mapped to 3, and 8 gets mapped to 4. We have this other line. And again, I'm going to label that f inverse. What's actually occurring when we switch all of those x's and y's, so we say it's happening, if you look at it, the function f is a reflection across this line that I'm drawing. This line is as for an equation y equals x. So that would mean like 1 corresponds to 1, 2 to 2, 3 to 3. And so what's happening is our function f is getting flipped over to f inverse. So we have this reflection across the line y equals x. Now let's see, here's our try this. How do you find the inverse of a set of ordered pairs? Let's say of a function written as a set of ordered pairs.